Hi and welcome to another Motec webinar. My name's Pete Swinney and today's subject is tuning engine charge cooling on an M1 ECU. Engine charge cooling is the parameter used to offset the effect that richer mixtures have on manifold air density. Now what that means is that the mixture from say lambda 1 to lambda 0.8 or lambda 0.75 obviously gets richer, and it has a different effect on the density of the air after the air goes past the injector. So this air we can measure through the manifold temperature sensor up to the injector, but we just don't know how much richer it gets after the mixture gets richer from any known tuning point. Alright, so effectively the M1 attempts to model this. The richer the mixture, the cooler the charge will be, and the more dense the charge will be. But each engine's different, injectors are different, spray patterns are different, fuels are different. So there's a parameter there to help fine-tune that behavior and allow the M1 to very accurately predict the exact pulse width required for any mixture request. The important thing to note here is that the M1 will follow or attempt to follow the fuel mixture aim table. If you are set currently to 0.9 everywhere and you aim for 0.8, well, the M1 will automatically make the injector pulse width longer and attempt to get the mixture, the eventual mixture, without using closed loop, straight to 0.8. So in normal circumstances it will do that, and if it doesn't do that, usually the only parameter left to adjust is the engine charge cooling. Now of course this relies on you entering accurate injector calibrations and fuel pressures and things like that. So all the calibrations and relevant information about the engine and what's used need to be entered into that workbook, which is the initial setup workbook, and all those worksheets that we actually cover in a separate webinar. So assuming you've got all that accurate and things are set up and going, you then place the engine steady state at approximately a third load. Now the key thing to remember about this adjusting this parameter is it will affect your efficiency table numbers. So it's no use doing a full engine tune and then deciding, oh, I'm going to adjust this engine charge cooling parameter. If you move it much at all, any more than sort of 5 or 10%, you'll have to retune your efficiency table all over again. Alright, so the best thing to do is get the engine going, get it to about a third load, tune the efficiency map at that point so you've got an accurate lambda and everything is running to the aim, and then check for an aim change and lambda tracking of that aim change. So for instance, if we're at 0.9 and engine's happily running following our aim of 0.9, at that same load site we simply go to the mixture aim table main and change that to a richer or a leaner mixture, and the lambda should just track perfectly what that aim request is. If it doesn't track, then we need to adjust the engine charge cooling parameter. So if you need the lambda to swing less, you make the engine charge cooling number less. If you need the lambda to move more, you make the engine charge cooling parameter larger. Alright, probably the best way to explain this is to simply show you. So we'll switch over to M1 Live software now, and we're online to an engine at this point. You'll see we're sitting in the fuel mixture aim table, and we're going to work between the fuel mixture aim table, the efficiency table to make sure our tune's right, and the initial setup workbook and the engine details worksheet, and there's the engine charge cooling gain parameter. Alright, so by default it's going to be around 23. I'm actually going to make it 30 and we'll get it settled in at that, and we'll get started and see how it goes. Alright, we'll just start the engine and get things fired up here. Turn some fans and things on in the dyno. Alright, so the first process is to get the engine to on site somewhere around a third load. As I said, we've got F5 allocated to the fuel map. I'm going to choose 50% throttle, which is 50 kPa or close to it, 2750, and we're sitting reasonably close right now. Takes a little while for it to settle after just being started, especially when you do a test like this. Right, so F8 is allocated to the fuel mixture aim table, sitting at lambda 1 aim. Still a little bit unstable. Just to have a bit of a look and see where it is, we'll go to 0.8. So I'm aiming for 0.8, and you can see on our time chart here it's gone way too far. So we're asked for 0.8 and it's gone to 0.74. Right, so making the number smaller makes the swing smaller, so that's what we're after. We're a little bit under our aim there, but it's definitely miles too much. So we want to come down to initial setup and reduce this down a significant amount. And of course this is going to change the tune-up itself. It's going to change our efficiency map. F5 back to there. And what I want to do is actually tune it lambda 1 here. So I'll make my aim lambda 1 again. Okay, it's a little bit lean. We'll just get over here. We made a large engine charge cooling change, and you can see it's a little bit lean here. We want to get it just spot on, so we'll do that. Just push Q then. So that's pretty close. So F8 across and sitting pretty close now. Now we'll go down to 0.9. Alright, and that's, you can see, is pretty accurate. So as you see, the aim, the fuel mixture aim, which is being derived from the fuel mixture aim table, main table here, you can see the state, and that's pretty close. So if I go from 1 to 0.9, this is not doing closed loop, this is just the M1 predicting the correct amount of fuel for the airflow of the engine and the request. Alright, it's pretty close. We'll make a bigger number now. We'll go down to 0.75. Alright, pretty good. Back to 1. Alright, that's actually fuel film that's causing that to be slow like that. It's a little bit under now. We can just flick back to the efficiency map. It's pretty close though. F8 back to the fuel aim, 0.9. Alright, that's pretty close. That's within a few percent. And obviously you can work on that and get it as accurate as you like. And then what will happen, I'll just bring this down to idle now, make it a little quieter. So the main intention of that is to get that to follow correctly for different air fuel ratios. Different mixtures, as we said, affect the density. Once that's done, you can then have the M1 have any sort of fuel mixture aim request, whether from the main table. Here's the list of other tables: the auxiliary output fuel mixture aim, auxiliary time fuel mixture aim, coolant temperature fuel mixture aim. All of these are tables you can program to get richer if any of them are in distress. Race time, throttle position, anything like that, we can have dedicated fuel mixture aim, and as long the richest of any of these tables here, or the fuel mixture aim table, wins. Alright, so it becomes whichever is the richest table becomes the feed for the fuel mixture aim channel. Now just to give you an idea, I'll pop the aim here back to 1. I'm just sitting at idle here. I'll just make that 1. Alright, it's still the richest out of all these tables, but what we'll do is we'll make the coolant temperature table. Alright, it's sitting at 2 there. I turned it off to make this demo a bit easier to understand. So we'll make that 0.9, and if you watch down here at the fuel mixture aim state, alright, it's aiming for 1 at the moment. When I press enter here, it'll go to the temperature. Coolant temperature is now driving the fuel mixture aim, is now gone to 0.9 because this is now the richest mixture. So there's no longer compensations on fuel, there are dedicated fuel aim tables. If you get this engine charge cooling parameter right, then each of these tables, as they get richer than your fuel mixture aim table, your main table, the M1 will automatically adjust the pulse width to meet that fuel mixture aim channel. Alright, it's as simple as that. That's not in closed loop. There's the fuel closed loop trim parameter there. That's off, or that bar graph shows us rich and lean, or percentage trim negative and positive. That's just following the aim. Right, it's not doing a perfect job at idle on an engine with a big cam and multi-throttle bodies, but it's not too bad. So hopefully that explains how that works. There's always plenty of help by pressing F1, and hope you understood it, and we'll catch you next time.